Hello everyone, welcome back to my channel. In this video we are going to cover ABB ACS880 diagram or drawing. So it will contain both power circuit and control circuit. So guys, this video is in English language और अगर आपको हिंदी में ये वीडियो चाहिए तो उसका लिंक मैं डिस्क्रिप्शन में आपको दे दूँगा. So let's start the video. And this video is important because like ACS 880 is important because ACS 800 and 850, those models are going to be obsolete and those will be replaced by 880. So without a further ado, let's start the video. We will start with page number 3, that is single line diagram. From left hand side bottommost you can see the main supply is given to the complete circuit, that is 415 volt plus minus 10% tolerance, 50 Hz frequency plus minus 5% tolerance, 3 phase. So this is the main input to the drive. The first tapping you can see here is for MPCB and the rating is given for all this switch gears. For this it is 0.16 to 0.25 amps and this is for RYB indication. Once you switch on this MPCB you can see that main supply is there or not. Next, if you'll go ahead, we can see there is one more tapping for VAF digital meter, that is voltage, ampere and frequency. Okay, further you have to go ahead with Q1, that is MCCB. So this notation is very important. This notation will be used further in the drawing. Q1 is for MCCB, that is main molded case circuit breaker, and the rating here you can see is 630 amps. It will vary on rating of the drive. Again we have to go ahead and see the another tapping, that is for Q21 MPCB, and the rating here is also less, 0.25 to 4 amps, and this is for control transformer. Here you can see the symbol of control transformer. Main supply is 415 volt and we will take two phase here. Here this is single line diagram, it is not quite properly clear, but we will take two phase here for 415. And next, this control transformer is further gives two different voltage level. One is 110 volt and this will go to F22 MCB, which is used for control supply, we will see ahead. And another is 230 volt output, and there you can see the first tapping is for F25 MCB, and that is used for panel illumination. Next, if you go ahead you can see K26, okay, that is the contactor, and this is further tapped into two different MCBs and both are used for panel cooling fans, F26 and F27. Okay, so this is the part, this is the job of the control transformer to divide the voltage, and the rating you can see for the control transformer is 1000 VA or 1 kVA. Going further on the right hand side you can see fuse F1 to F3. These are the three different fuses, and after fuse the main supply, the three phase supply will go to the drive. Here you can see ACS 880, it is mentioned, rating 505A amperes and model number, and further it is the output that will go to the motor. Here you can see for this particular model the motor rating is 200 kilovolt. So that's how it will go. And next, on the very right hand side you can see it's a UPS supply. It is for the customer scope, so it is not given in the drawing. Just in case if you want to keep the drive running, if there is a power supply, we have to use this diagram, else we can skip it. After single line diagram, next we'll come to power circuit diagram. We'll start from the left hand side again, and here you can see the three phase supply. It's again 415 volt plus minus 10%, 50 Hz and so on. And the very first tapping what we have seen in single line diagram is F5, that is MPCB, and this tapping is for indicating lamps. So once this MPCB we switch it on, we can see the indicating lamps glowing for red, yellow and blue color. With the same tapping it is given to VAF, that is voltage, ampere and frequency meter, digital meter. So it's a line voltage, here you can see this system will get. And again going back to on the top, here we can see the current measurement. So there are three different CTs, B 2.1, 2.2, 2.3, and the ratings are also given 600 bar 5 amps. that is primary and secondary ratings of the current transformers. And this will go to again VAF digital meter, and this will show you the line currents. So with the help of line voltage and line current, this meter will give you three readings, that is voltage, ampere and frequency. Next, going ahead with current measurement CT, there is Q1 MCCB 630 amps, and further there are two tappings taken which we will deal in another page. Going ahead, we can see the fuses on the most right hand side, F3.1 to F3.3, and the rating is also provided 170. And further, after the fuse, the main supply will hit to our drive, that is U1, V1 and W1. That is the input terminals of the drive. And after this, AC is converted into DC and further into AC, that is variable AC. Here we can see the output from the drive, that is U2, V2, W2 will finally feed to the motor, and the motor will run according to the reference given. Next we'll come to the another page. In this slide, we will discuss the tapping, what we have seen in the previous slide. The tapping is given for control supply distribution Q21. Just for reference, you can turn the previous slide and you can see there is a tapping which we haven't discussed in the previous page, that is Q21. So it will contain 415 volt, two phases of the three phase supply, and there is a MPCB. Okay, once we'll switch it on, it will feed the transformer, that is control transformer 1 kVA, the rating of the transformer, and the output of the transformer is of two different powers. One is 110 volt and another is 230 volts. So first we'll discuss the 110 volt. This will feed F22 MCB, and that we will use for control supply. Coming on the left hand side, that is for 230 volt, the very first tapping you can see is for F25, that is MCB again, and it is used for panel illumination, CFL and different lighting equipment. Next, it is K26, so it will feed two different MCB. One is F26 and another is F27. Both are used for panel cooling. Here you can see on the left hand side there are three panel cooling fans, and for drives panel coolings are very much critical. It is more important for than you can say DOL or RDOL or any other starters, because for drives the heating, to take out the heat generated in the drive, is very critical. The temperature can go up to 50 and 55 degrees Celsius. So cooling fans are very critical in drives. If we don't have a cooling fan, the drive will continuously trip on over temperature fault. Next, let's come to the control card connection directly. So here you can see the on the on the right hand side corner, it is mentioned ZCU 12 control unit. So ZCU, the full form of ZCU is Z series control unit. Earlier for ACS ABB you have seen GCU cards. So that was J series. So the very first thing is external power input, and this supply is given with the UPS supply, what we have skipped because that was not in the scope of ABB. Just in case if there is a power failure, so this supply is provided, else you can skip it. Next is X13, that is control panel PC connection. It will come from assistant control panel. Here you can see from the left hand side to right hand side how it is provided. Next is the channel number 10 for X23, which is for memory unit. So these are by default connections. We will skip and will come directly to XSTO, that is safe torque off, what you can see here. And here you can see the connection is between 1, 2, 3 and 4. Earlier in ACS 800 or 850 you have seen the connection between 1 to 3 and 2 to 4. So there is some changes here, that 24 volt is directly given from 1 to 3 and 4. Next, these are by default connection. We will skip it and will directly come to the bottom part, where we have to see the reference, how reference is given and how the feedback goes back to the PLC. So the very first thing is XAI, that is AXAI is the slot, and here we will directly go for channel number 6 and 7, that is analog input 2. and on the center you can see there is 4 to 20 milliamps speed reference from PLC. Okay, so the PLC will give command for on how much speed the drive has to run according to the PID control or according to the operation requirement. And this is the speed reference 2. We can also use if speed reference 1, and we have to, for that we have to select the jumpers. On the upper hand, on the upside of the speed reference, you can see the jumpers. Whether it has to be voltage control or current control, we have to select the jumpers accordingly. Okay, so speed reference is done. Once the drive is running, the PLC must also know on what speed and how much current the drive is running and how much current the drive is withdrawing. For that, we have analog output AO1 for speed, motor speed. This is a drive generated. The 4 to 20 milliamps drive will generate, and it will, this milliamps will get back to the PLC, and similarly how much current it is generating, it will show in PLC. All these settings we do in drive parameters. So for that you can consider, you can refer the different video. We'll come to the next slide. On the top we can see the slot XD24. So this slot is responsible for generating 24 volt internally. The control card will generate 24 volt, and it will feed different digital input. So digital input slot you can see just below it, that is XDI, and there are total 6 digital input. And we'll just see the first one because digital input will vary according to the application. You can design it on your own, go to the parameter and you can select your own as per the design, as per the process, which digital input you want. For example, the first one is start stop, and the 24 volt has to go through K24. Once the K24 is NC, normally closed, then 24 volt will come to this digital input TI1, and the drive will get the start command. Similarly for digital input 2, that is cooling fan on acknowledgement. For 3, this is external speed reference from LCS speed increase. Similarly for digital input 4, that is LCS speed decrease, and digital input 5, that is for LCS or DCS selection. Local, it has to run from local or from control. And lastly, this is important, that is digital input 6, that is run enable, and 24 volt has to come from K15. So what are this K15, K18, 20, all we will see in the next slide to come. Coming to the bottom part, there are different relays, R01, R02, R03. The voltage rating is 250 volt AC and 30 volt DC and 2 amps. In this different, all the three relays, there is an internal relay which will operate from 24 volt. So once the drive is internally healthy, the drive is healthy, so that RO1 internal relay will actuate, and the signal coming and going, that will happen. It will change the state. Similarly, if the drive is running, NONC will happen internally, and similarly with fault. Guys, next page is very important and it is named as common control logic. So here we can see the two lines. Top line is 110 volt AC and the bottom line is 0 volt. We'll start with the left hand side. So the very first tapping you can see here is X51 channel number 1 and 2, and in between that there is emergency stop button for LCB, local control box. Generally in normal condition it will be NC because push buttons are not pressed, so it will not get NO. If it is NC, 110 volt will get to external interlock. If we need this, we will use, else we'll put a loop, and it will get to another stop button that is provided on panel. If both are healthy, both are not pressed, then K15, that auxiliary contactor, that will actuate, and it is a signal that emergency signal is healthy. Okay, we'll get to the second tapping. K15, if K15 is actuated, 110 volt supply, if the auxiliary contactor has got, then K15 here, the second interlock, it will get NC, and it will go through K23. Generally K23 is healthy, let's suppose, and we'll see what K23 is in the next page. And 110 volt has come to the selector switch button. This dotted box you can see on the left hand side, it is LCB, and the right hand side it is DCS. So this will decide from which mode the drive will run, from local mode or from the PLC mode. If from the local mode the drive has to run, then 110 volt will feed to K17 auxiliary contactor, that is LCB selected. If the DCS has to run from DCS, we have to turn the selector selector switch on the right hand side, and key 18 will get the supply, that is DC selected. For example, we have to run the drive from LCS mode. Key 17 is selected and will come to the third tapping on the top. So key 17 will get NC closed. 110 supply will come, and it will go to stop push button. Okay, here you can see stop push button on a small dotted box. So small this small sorry stop push button is applicable. It will work only for fraction of second. Okay, but it will stop the complete circuit when required. So for time being, everything is healthy. 110 supply will come to this place, which is another dotted box on the center of the drawing, that is start push button. And once the start push button is pressed, 110 supply will get to K24, that is start stop command. Okay, so this is only for fraction of second, but to keep the system running we need a holding contact. So on the right hand side of the start push button you can see K24, holding contact interlock. Okay, so the supply will continuously feed 110 volt through K24. Okay, so this is the work of holding contact, hope you know. Next, if you want to run the drive from control mode or PLC mode, then key 18 has to get high and will come to the fourth tapping. Key 18 will get NC, and this command, the dotted box command, start stop DCS X52, channel number 3 and 4. This command will be continuously NC, and this supply will come from PLC, and the K24 auxiliary contactor will be healthy and the drive will continuously run. Next, if we have to speed increase and decrease the speed from local mode, then again selector switch has to be on the left hand side. K17 get healthy, and this fifth tapping on the top you can see K17 again. It will feed and it will go to two different speed decrease and increase part. Your dotted box, you can see the two dotted box that we have to press. How much speed we have to increase or decrease, we have to keep this push button press. There is no holding contact, but there are interlocks. You can see, this K19 is for speed increase auxiliary contact, and K20 is for speed decrease. So here you can see the both interlocks. Since we cannot give both commands simultaneously, so this is very important. We'll come to the last tapping, that is K22. Okay, what is K22 we'll see ahead. And K21, K22 is NC, then it will 110 will can come to K26 auxiliary contact, and that is used for panel cooling fan on command. So that's how it is, this part is covered. We'll come to the next part now. This is continuation of the previous page, that is common control logic page. And here you can see again 110 volt on the top and 0 volt on the bottom. And we'll start with the left hand side. So the very first auxiliary contact you can see is drive ready, K21, K22 drive run, and K23 drive trip. What we have seen while we were discussing the control unit card, there we have seen those three relays. So these are three relay, and K21, K22, K23 we have used in the previous page to understand how the system will work. Okay, and how this 110 volt will come and go to this auxiliary contact. Here you can see in the dotted box. See this dotted box, what is written here. You can compare with the previous slide. You will get to know the proper idea. When drive will run, when drive will trip, and when drive will show the ready command. Next we'll come to the half section of this page, that is speed signal and current signal. So for that we need isolators. Okay, here you can see the current signal isolators or transducer you can say, and the input is 4 to 20 milliamps. Okay, and with one signal the output will be two signal, 4 to 20 milliamps. One will go to the PLC and one will go to the field. Same thing happen. And why transducer are used, what is the importance of isolators, there is a separate video. I'll drop down the link of those video. And that is it, that is the function of the isolator. One signal will get converted into two that have to be used in PLC and in field. Next we'll come to the another page. So the three release what we have seen, that drive ready, drive running or drive trip indication is there. How the layman, how the technician will get to know whether the drive is running or it has got tripped. So for that, indicators like white light is there, green light is for running, and amber is for trip. And all these three is provided with three different parts of the contactor, auxiliary contactor. So K21, if drive is ready, it will get NC and this LED will glow 110 volt again. Similarly for K22, running indication green, and K23, one part of the contactor is used for drive trip. This is how the indication system works. Next we'll come to the different, the connections. The first thing here you can see is for LCB connection, that is LCS connection. You have heard me like saying X51 channel number 1, 2, 3, 4 and all those things. So these is X51 slot, and the first channel and the second channel is for LCB emergency stop. Okay, emergency push button signal you can symbol you can see. Then channel number 3 and 4 is for LCB start, that is push button. 5 and 6 is for LCB stop, again the push button. Next 7 and 8 is to speed increase, 9 and 10 is to speed decrease. We have to keep hold all this. I mean the for this two, speed increase and decrease, we have to keep it hold. But the first three is for one time. Emergency button is pressed one time, start button is pressed one time, stop button is pressed once. Okay. Then X51 again, it is 11 and 12, and this is for selection. Okay, whether the system has to work from LCS or PLC DCS. So 11 is common, 12 is for LCS, and 13 is for DCS. And lastly it is for digital meter current signal. If required we will use it, if not we can skip it. Next we'll come to another slot, that is X52. This is for DCS, and the first one is first channel and the second channel is for interlock. If required we will select, if not we can skip it. Third and fourth is for start button. you know this signal will come directly from the control. If it is running, okay, if not it will be no. Next, digital outputs, this dotted, the middle one. So X52 channel number 11 and 12 is used for drive ready, K21. Similarly for drive running, K22 has to get NC, and similarly K23 has to get NC for drive trip. These are all DOs to DCS, digital output. Next, DCS selected, what we have seen earlier. Again K18F gets selected, so the PLC will get an indication that yes, DCS has been selected. You can give the start command. X52 again, 3132 is for 4 to 20 milliamps speed reference. After that 33 and 34 is for signal, the feedback from panel for speed, for how much speed the drive is running. And the last one is 3536 is for current signal, how much current the drive is withdrawing. Okay, so this is how it is completed. So guys, we have come to the last page, that is panel illumination diagram, and it will contain space heater and all those things, so which is not that important, you can check it for yourself. And I hope this video was useful for you. If so, please like, share, subscribe and share with your friends so that we can spread knowledge and will have a better reach. And if there is any confusion somewhere, you can just drop a message. And I thank you for watching. Nothing else to say. Thank you.